In case you were absent today, we were talking about the features of rational functions today. And so our parent function for all rational functions is f of x equals 1 over x. And we should recognize this as this graph. So notice, are there any zeros? Nope, not crossing the x-axis at all. What about the y-intercepts? Nope, not crossing the y-intercept. And behavior, as x goes to infinity, y gets closer and closer and closer to 0. As x goes to negative infinity, y again goes close to 0. Right, so to the right goes close to 0, and to the left it's going close to 0. Vertical or horizontal asymptotes. Well, if we notice, vertical asymptote here is the y-axis. It gets closer to the y-axis but never touches it. Y-axis is x equals 0. Horizontal asymptote gets really close to that x-axis but never touches, so it's y equals 0. Even or odd or no symmetry. If I turn this upside down, it looks exactly the same, so it has odd symmetry. So this is one of our 12 basic functions. We've talked about him before, and we should know exactly all of these features and what he looks like. And based on this, we can figure out what these transformations look like. So if we look at our first example, I have y equals 1 over x plus 2. This x plus 2 is in the denominator. It's with my x. It's an inside change. Therefore, I know this guy is shifting to the left by 2. So if he's shifting to the left by 2, that must mean that this vertical asymptote of x equals 0 is now at x equals negative 2. And so I'll draw my vertical asymptote here. So I can tell the vertical asymptote is x equals negative 2 by either recognizing the shift, that it's moving to the left, or by looking at where the function is undefined. And at negative 2, I would get 0 in the denominator, and I know that's where it's undefined. Horizontal asymptote, well, there's no outside change, so this guy did not go up or down, so it would still be y equals 0. X-intercepts, well, again, this guy did not go up or down, so it looks like this function will never cross the x-axis, so there's none. The y-intercept, well, since he went to the left, this guy probably crosses now at the y-axis, so let's figure it out. I know anytime my graph crosses the y-axis, that x must be 0. So I can plug in 0 for x, and I get 1 over 2, so 1/2. So at 1/2, I have an intercept. And now to sketch it, it's the general shape. I just need to make sure I go through any intercepts. I get close to my asymptotes. And it's the same shape. Close to my asymptote, don't touch. Let's look at the second one. Well, now I don't have an inside change, I have an outside change. Now my function is shifting up by 3. So, vertical asymptote, well, where is this guy undefined? At 0. And since he didn't move left or right, it's still at 0. Horizontal asymptote, well, now he's shifting up by 3. So my original function had y equals 0. Well, now if we go up by 3, it's y equals 3. Intercepts, well, x-intercept, I know anytime my graph crosses the x-axis, y is 0. So I can plug in 0 for y equals 1 over x plus 3. I'll subtract 3 equals 1 over x. Put this over 1 so I can cross multiply, and I get x equals negative 1/3. So there's my x-intercept. Y-intercept, again, I can plug in 0 for x, but 1 divided by 0 doesn't happen, so there's none. I can also recognize this. If my vertical asymptote is x equals 0, that means I'm not touching the y-axis, so there's none. And then to graph these, so for the vertical asymptote, it's 0, so that's just the y-axis. Horizontal asymptote is at 3, so I'll make a dashed line. I have an x-intercept at negative 1/3, somewhere there. And so again, the same shape, close to my vertical asymptote and horizontal asymptote. close, but make sure you pass through your intercept. And there's my sketch. Now suppose they give me the graph, like in number 7, they give me the graph, and we want to write the equation. So let's recognize where the vertical asymptote is. Well, looks like it's over here somewhere, so looks like x equals -4. And then the horizontal asymptote somewhere over here, that kind of looks like y equals 4. And so based on the vertical and horizontal asymptotes, I can come up with my equation. Remember, my vertical asymptote is my horizontal shift. So if it's -4, I can write x plus 4. And my horizontal asymptote is my shift up or down, so I have plus 4. And so I've come up with my equation based on the vertical and horizontal asymptotes. One other thing we need to know is, what if we're given the rational function in this form, and we want to get it back into transformation form? Well, we can do this by using synthetic division. Since I'm dividing by x minus 4, I can place 4 on the shelf. And then by synthetic division, this would be 1, this is 3, squiggly, draw my line, drop the first guy. 1 times 4 is 4, 3 plus 4 is 7. If this is x to the first, then he must be x to the 0, which means that's just my constant, plus my remainder over the divisor. And I can switch this around to make it look exactly like that. So I can put this first, plus 1, and now I can clearly see that my vertical asymptote is x equals 4, and my horizontal asymptote is y equals 1. We'll do one more together. So here we're dividing by x plus 5, so I will put -5 on the shelf. And then we have 1, -4, squiggly, draw my line, drop. 1 times -5 is -5. This is -9. This guy is x to the 1, so he's x to the 0, just my constant, minus 9 over my divisor. Again, we can write it just so we're used to seeing it in exactly this form. X plus 5, and then this is plus 1. So I can see my vertical asymptote is x equals -5, and my horizontal asymptote is y equals 1. So this packet is to be completed for homework. Have a good weekend.